Hi, I am Arib. You are watching my YouTube channel. Star versus Delta motor connections. Star connection has different line and phase voltages. We know that the line voltage will be the same whether the connection is star or delta. The change happens in the phase voltage when the motor terminals are connected in a certain way. If we recollect the formulas for line and phase voltages for star and delta connections, we can see from the formula above that the phase voltage of delta connected motor is the same as the line voltage, whereas the phase voltage of the same motor, when connected in star, will show a smaller voltage. Delta connection has different line and phase currents. Unlike line voltage, which stays the same because it's from the supply, the line currents for motors will change based on several factors. For example, the motor's power, load on the motor, power factor, motor connection type, etc. If we are only discussing one motor running at no load, we narrow the difference down to mainly one factor, the type of motor connection, whether it's star or delta. Delta-connected motor will draw more line current. According to the formula for line and phase voltages in the delta connection, we understand that they are the same. Whereas, as discussed in the first question, the phase voltage in the star connection is less than the line voltage. Therefore, if we use the same motor in both connections, the voltage across the phases, windings, of the motor will be higher in delta as compared to that of star considering Ohm's law. If the load doesn't change and the voltage increases, the current drawn by the load also increases. So we can safely say that a motor connected in delta will draw more phase current than the same motor connected in star. The formula for line and phase currents of delta connection describes that the line current will be SQRT 3 times higher than the phase current. Star-connected motor will draw less starting current. Using the explanation from the previous question, since the motor is the same, but the voltage is less across the phases when connected in star, the phase current will also be less. Contrary to the delta connection, where the line current is higher than the phase current, in the star connection, both line and phase currents are the same. One of the reasons why star-delta starters are used is because of the less starting current in the star connection stage, which provides less starting torque and puts less mechanical and electrical stress on the system, thereby increasing its lifespan. So if a motor is connected in star, it'll draw less starting current than if the same motor is connected in delta. So the answer here is star connection. Delta-connected motor will provide higher torque. The previous two questions discuss the currents of the star and delta-connected motors. We understand that the line current of the delta connection is higher than that of the star connection. Since the line voltage stays the same and while keeping the same load, we can say that the motor torque is relative to the current drawn. Higher current means higher torque, and lower current means lower torque. Delta-connected motor will draw more line current, so the torque it produces will also be higher compared to the star connection of the same motor. Neither type of motor connection require neutral. One of the functions of a neutral conductor is to carry the out-of-balance current from a three-phase circuit. However, balanced three-phase loads consume the three-phase power evenly and allow the return current from each phase to pass through the other two phases, leaving no out-of-balance current. This is why balanced three-phase loads don't need a neutral connection or conductor. Since a three-phase motor is a balanced three-phase load, it also leaves any out-of-balance current and does not need a neutral connection. So there is no need for a neutral, whether a three-phase motor is connected in star or delta.